looked at, she says confidently, so remember, if we were trying to find the area underneath this line, so this is fx, we don't know what that is. Yeah. It doesn't feel like a straight line. Should I change it so it doesn't?
Yes, please.
I like it.
Oh, it looks like a roll. That looks like a fun.
Alright, so this is some kind of function. We don't know what it is. We don't really care what it is. You would be told what it is if you were asked to do it. If we were trying to find this area here, we would integrate the function with respect to x, because it's to do with x. And if this was a and this was b, we would have b, a there. Do you remember that?
Yeah.
So integrating, finding definite integrals means that we're finding the area under a graph. This situation is that we've actually got two functions. And what we need to do is try and find the area in between them. Okay? So what we have to recognize is that if this red one was gx, if we were to find the area below that, we would integrate that between b and a. Okay? Easy peasy. But if we just want the shaded bits, why don't we have that colour? Let's do this. If this is the other function, what we would do is we would then subtract this area. Do you agree with that? And that is represented by that.
Wait, can you repeat what you just did on the phone?
So to find just the shaded part, so the blue, total blue part would be just the integral of g between a and b.
Okay.
If we just want the shaded, then we're going to have to subtract the integral, the definite integral of f,
Okay.
because that's the green bit. Yes? And that leaves us just with that shaded bit there. So, you've got options. Can't remember if it's on the formula of it. Maybe we should have a look. You've got options. You can either do them, find the definite integral of this one and subtract the definite integral of that one. Or you could subtract the function, so you would have one function subtract the other, simplify it, and then integrate that. Okay, so they're your two different options. Neither is better than the other. Sometimes this one may be a little bit quicker because you're not finding lots of definite integrals, but don't panic if you would just rather do this. The only thing that you need to recognize is which of the functions is on the top. Okay? So in this case, this g was on the top and the f was on the bottom. So that's why it was g subtract f. They're not always going to have nice pictures like this. Sometimes you're going to have to think about it more carefully. And this example is a prime one. So the question here, it says, find the area enclosed between these two curves. Well, first of all, we need to know what our limits are. Okay? To do that, we're trying to find where our two graphs intersect each other. At this point, we think, aha, I know how to find intersecting points. I'm going to equate my two functions together. Yes? So I would say that x squared plus 2x plus 2 is equal to negative x squared plus 2x plus 10. I've rearranged that. So I have 2x squared. Now I've got plus 2x on both sides, so actually they disappear. And then I've got 2 subtract 10, so that's negative 8. Now, you can solve that however you would normally solve it.
So wouldn't the x squared cancel out since one?
No, be careful because this is negative x squared.
Oh, so
Okay, so when we yes. Okay. So we've got 2x over there, 2 minus 8 equals 0. Now, if it's on the calculator paper, you can stick that into your polysmalt and solve it. Ideally, you would recognize that you've got a common factor of 2 here. okay? And then you should be recognizing what's this here. Pardon? Quadratic, and it's a special quadratic. What is it known as?
Square.
Yeah, the difference of two squares, yes? So when we factorize the difference of two squares, we've got, could go, Olivia, plus, was that you? Yes, plus 2 minus 2. Alright? So that tells us that my two values where these graphs meet are the opposite of this, which is the -2, and the opposite of this, which is the +2. No, because the 2 at the front makes no difference. In order for this whole expression here to be equal to 0, we're only interested in the brackets, because as long as one of these is 0, the whole thing's going to be 0. Okay? Right.
How do you negative?
Because 2 subtract 10, so I had to move everything to the same side because I had to equal 0. Okay? Alright, so that's just finding those two values. So that was a little quick review of solving quadratics. Then we need to establish, okay, well, which one of these is on the top and which one is underneath? What do we know about this function? It's a, what kind of graph? It's a quadratic, so it's a secretly parabola.
Oh.
And is it positively happy or negatively sad?
Positively happy.
Okay, what about this bad boy?
Negatively sad.
Alright, so in order for our graphs to intersect each other, this one's going to be the one on top. Do you appreciate that?
Yeah.
Yes? So this one here is going to be our G, if you like. What is this one? Sorry. And then this one would be F. Does that make sense?
Mm-hmm.
So, I'm following the whole G, take away F. So you don't actually need to write those because I've done those for you. So you've got function G, subtract function F. Remember we're subtracting all of this. So we've got negative x squared, take away another x squared, gives me negative 2x squared. 2x subtract 2x, that's gone. And now 10 subtract 2 is 8. So this is now going to be the expression that we're going to integrate. So remember we add 1 to the power divided by the new power. When there's just a constant, we just add our x. No need for the c because it's the definite integral. And we chuck our limits at the edge. And then we substitute those values in. So, sticking a 2 in place of the x, and now -2. You get these values here. Okay, so as I say, I've done the hard work for you. And I've changed them both to be fractions of the denominator 3. So obviously at the moment this is a 1, so we're going to multiply both the top and the bottom by 3. Same thing with this one. So that's where I get these ones. And we've ended up with 32 over 3 plus 32 over 3, which is 64 over 3. So there's a lot of fraction information there. If this was on the calculator paper, you would be able to chuck it all in actually. Do you remember how to do it on the calc? Which button do you press?
Math, then 9.
Math, then 9. Okay? And then you just chuck it all in. Right? So we'll practice doing that as well.
For integrals?
So that,
Yeah.
well, to be honest, you can do math 9 and then you could type all of that in there. Okay? As long as you knew which one was at the front and which one was at the end, it will do the whole thing for you. Okay? And so this, when you press this, it comes up with this.
But on the calculator paper, don't we still have to do like how we did it?
So on the calculator paper, yes. So I would like you to write this, but you could probably skip from this one down to the answer. because you will notice that the marks allocated to it will not be very much. Okay, so as long as you're showing, someone needs to turn their phone off. As long as you're showing you're working and what you're chucking into the calc, that's fine. Okay? Just the ants. Oh, that's that. Alright, so example 2. Find variant grows between the curve and the line below. So what did we have to do first of all?
Which one?
For the what?
Which one on top?
That wasn't our first thing. What was our first thing?
So those equal each other.
Yes, because we're finding where they
intersect.
intersecting points. Yeah. So we're finding intersecting points. So if y is equal to that and y is equal to that, it must mean that they are equal to each other. I don't know why it's start with that one. Alright, so there we have to move everything to the same side because we can see that we're going to have a quadratic and then we have to, it has to equal 0 to solve it. So we're going to subtract x from both sides. Oh, you did the one as well. Yes, check you out. Okay, if it's equal to 0, we're going to solve that by trying to factorize. Remember, that's our easiest option. So we're trying to find two numbers that do what and what.
Multiply and make 3. 4.
Almost. Careful.
We multiply it like
Negative 4. Okay, so then multiplying to give negative 4 and
add and 3. Negative 3.
and give negative 3. Good. Which numbers multiply to give negative 4 and add to give negative 3?
Negative 3.
1 and 4. And I did 4 and 1.
Which way around is it?
Negative 4.
4.
Okay. Which means our two values, remember they're the opposites. So it's going to be x equals 4 or negative 1. Right, so they're going to be our limits. That's going to be our A and our B. So now just know what we have to decide?
If it's which one's on top?
Which one on top? So visualize what kind of graph that is. Parabola, yes? What kind of thing is this?
Line.
Kind of line?
Straight.
Straight line. So in order for there to be an area, it's got to be going through it like that, yes? Which means that the line, the straight line is the one on top. Yes? Do you see how that thought process works? So that means that I'm going to find the integral between 4 and negative 1 of x plus 1 subtract x squared minus 2x minus 3. Now we'll do it without the calc, just so we're comfortable with doing it. Remember, you're subtracting all of the right-hand side. So we've got x plus 1 subtract x squared plus 2x plus 3. I'm going in baby steps.
So you find out which one's on top so you can multiply that, have that first?
Yes, because the top one has to go first. Because if you do it the other way round, it's going to go wrong. So then we've got negative x squared plus 3x plus 4. So far, all we've been doing is establishing which one's on top, making sure we subtract the correct one, and simplify it. So now we've got our function that we can integrate. So we can follow our rules of integration. Add 1 to the power, divide by the new power. So we've got negative x cubed over 3 plus 3x squared over 2 plus 4x. Hang on, square bracket and hang the limits at the end. And then we're going to chuck those numbers in. So, negative 4 cubed over 3 plus 3 squared don't forget, brackets are super important when you come to substituting these things in, especially when the value is negative. So 4 cubed, 4 multiplied by 4,
15.
and then multiply that by 4.
32. No, not 32.
16 multiplied by 4.
16.
64, nice. So we've got a negative 64 over 3. 4 squared is
16.
multiplied by 3.
32. 64. I don't know.
Okay, stop chucking numbers at me. So 16 multiplied by 3. So we've got 10 multiplied by 3. And what's 6 multiplied by 3?
No, I was thinking 180 because 18.
So add those two together.
18 is right. Yeah.
And then 4 multiplied by 4. 16. Yeah. So we've got negative 1 cubed. Negative 1, but then we've got a negative sign in front of it. So that's now going to make that positive. And then we've got negative 1 squared, which is going to be, negative 1 squared. 1. Remember it's 1. Negative 1 multiplied by negative 1. Yes, yeah. Multiplied by 3 gives us 3, negative 2. And then 4 multiplied by negative 1, so it's going to be subtract 4. Let's try and join some of these together. So I'm going to do my things with denominator of 3 together. So I've got negative 64 over 3, subtract 1/3. So that's going to be negative 65 over 3. You happy with that? So I did those two. They've both got a denominator of 3. Yes, so negative 64 over 3, well I subtracted, yeah? Because I'm subtracting 1/3. This has got a take away sign in between. Now let's deal with my thing with denominator of 2. So I've got positive 48 over 2 plus 3 over 2. Oh, shut up, Harrison. We're taking away 3 over 2, sorry. So that's 45 over 2, yes? And then we've got 16 subtract negative 4.
Okay.
Nice.
Is it negative 1, 2, 3, negative 1?
Yes. So this would be negative 1, but then you've got a negative of that. Yeah? So that's why it's important we do everything in the correct order. We do our brackets first. I mean our powers. Our brackets. Anyway, shut up. Right, we need to join these together now.
Times 2 times 2 times 6.
So, yeah, this has got a denominator of 1, so we're going to make them all 6s. So these have got to be multiplied by 2. So that gives us negative 130. Lots of mental maths going on here. This one's got to be multiplied by 3. Ooh, what's that? Hopefully you do that in your head.
I was so tired.
Oh, I'm sorry.
Probably gonna go
One thing.
Yep.
One thing. Yeah, I was gonna do it too.
Oh, I know, I'm ruining everyone's fun.
Sure.
I guess when I'm on the recording now. No, so see on TV.
So, we've got negative 130 over 6 plus 135 over 6. So we've got negative 130 plus 135 gives us 5, because you've got only one negative 130 and you've got added 135, so it's 5 over 6, plus 120 over 6 is 125 over 6. That's it? Yeah. That's
Sounds
it.
disappointed.
I was just happy because I ran out of space.
Oh, yeah, I see.
Oh, I gave you the right amount today.
Show me your look.
Oh, they gave the whole page. Alright, so, I'll stop that and then let's, oh, look, we're at 20.